A mobile API doesn't have to be specifically targeted for a mobile app. Thing is, there are many people who come from a mobile background. They want to build a mobile app, and they have no idea how to build an API. So that's who my presentation targets, but it should be relevant to pretty much anyone. OK, so here is a ranking of the most downloaded apps ever on the App Store. As you can see, on the 10 most downloaded apps, there's only one that doesn't actually rely on networking. So the top 9, they simply just don't work at all if you don't have an internet connection. So that's definitely extremely significant. If you want to build a mobile app, you will need internet access at some point. OK, so you don't have to use HTTP, but if you don't, you'll run into so many troubles that basically everyone uses HTTP. OK, so I said HTTP is the lingua franca of the internet, which means everyone is using HTTP. Let's take an example, for example. You'll want to stream videos over the internet. Years ago, you had like RTSP, tons of different protocols. Nowadays, somehow we reinvented the wheel, and everyone uses HLS. HLS is HTTP live streaming, which isn't such a good protocol, to be honest. But it's over HTTP, and so it will just work. Here, the assumption is if the end user has access to HTTP, he'll say, I have access to the internet. And if he's behind a firewall that blocks UDP or whatever, he doesn't matter as long as he has HTTP access. So long story short, you want to make a mobile app that uses the internet, go with HTTP. Don't even think about any other possibility. OK, so here is the server side of things. I'm pretty sure everyone here knows about this. It's a very large picture. But to some people who are really mobile-oriented, they don't know so much about the back-end stuff. So here is a typical HTTP server stack. So you have an underlying operating system, a Unix probably, and a web server, a database engine, and your API code. So if you're from a mobile background, you don't have to host your code. You put it on an app store, and Google or Apple will handle it for you. So that's new to people with a mobile background. They have to host their server, and basically you have two choices. Either you rent a machine or a virtual machine, or you rent a platform. So let's dig further. OK, if you go to a machine provider, for example, Amazon EC2, OVH, whatever, there are tons of them, you'll be renting a raw machine. You'll have to set up your own operating system, your own web server, your own database engine, etc. If you go to a platform as a service provider, most of this will be handled for you. So the web server, the database engine, the operating system, everything will be taken care of for you. But there is a catch, obviously, the price. So here is an example of an average machine. So monthly, it will be about 30 euros for the hosted machine versus over 1,000 euros for a platform as a service. So the difference is huge, as you can see. So most people will say, OK, I'll just rent a hosted machine because it's so much cheaper. Well, it seems cheaper, but of course, well, you have to handle by yourself OS updates, redundancy, backups, handle failures, and this will take a lot of time. So depending on what your core business is, depending on how many machines you're going to handle, it's really not simple. So really, you have to be able to switch. For example, start on a platform as a service provider, with a platform as a service provider, and later on switch to your own architecture, for example. This means two things. First, you have to keep a clean separation between layers. You don't have to rely too much on, for example, let's say you want to go with Google App Engine, for example. Well, you have to be careful not to use proprietary software that will tie you forever to Google App Engine. And second, it is a really good idea to to actually make assumptions. So for example, don't try to have a code that's going to be able to run on tons of different databases, for example. You can say, I want to target, for example, Postgre, and I will use it forever. That does make sense because you can deploy Postgre on tons of different hosts. OK, so you've got your platform covered. Now, let's give a look at the actual API. So at APIdays, we've built tons of mobile APIs. And even though they aren't so different from APIs in general, there are a few edge cases where you want to be careful. Once again, this presentation is for a very broad public, so maybe you'll know most of it. So first of all, you want to actually design a REST API. This is new to many, many people. The concept of designing an API is not obvious to many people. So, OK, who hasn't heard of REST here yet? OK. So that's a good one. You have to version your API because mobile clients don't have to update. When you're on the web, everyone runs the latest version pretty much, or at least whatever version you decide. When you ship a mobile app, people don't have to update. They can remain on an older version. So, well, that's OK, but you have to be very careful because that means you'll have to maintain an API, and if you make any changes to your API, you have to be careful not to break previous version of the app. So a good practice here is to version your API. You can put it pretty much anywhere you like. You can put a version number in the actual URL. You can put it in the host part if you like. It doesn't really matter as long as you take care of that point, and you have to think about it before shipping the first app. OK. Now, this one is a bit tricky. Mobile clients tend to be extremely slow. So, OK, I'm going to give you guys an image. Imagine you're handling a huge supermarket, and you have tons of customers, and there are, for example, only 10 cashiers. So people tend up to wait in line because the cashier can only go so fast. And at some point, the line grows too big, and well, customers are annoyed. And somewhere you hear about a really fast cashier, someone that is going to be able to scan all your products in like 0.1 second. And you say, OK, my problem is solved. I'm going to use that super fast cashier, and customers are going to flow through, and it's going to be awesome. Well, yes, but not really, because a customer still has to pay, and that takes a while because he has to take his wallet out of his pocket. And so here the metaphor is, it doesn't matter if your server is extremely fast. You have to be careful about your clients. They can be slow, and you have to be able to handle that. And so back to the HTTP case, you have to stress test for slow clients to make sure your actual server is going to handle them well. And a good practice is to use a reverse proxy that's going to do that for you. OK, and this one is very important. It's also relevant to the general case, but even more so for mobile apps. So 3G networking is terrible. I'm pretty sure everyone here has experienced it before. And the only solution is to deal with it. So when you're going to design your next API, if you want to make sure it's going to be used and actually very useful on mobile, think about bandwidth. So try to minimize HTTP requests. A good practice here, let's take an example. You're designing an API for movies, for example, an API that serves information about movies. Minimizing HTTP requests means that in a single API call, for example, you'll be able to get a movie and all the actors at once. If you have a more simple API that would be along the lines of one API call for the movie and several API calls for actors, it is going to work, but it's going to be really slow. Second one is trivial, but pay attention to it. Use some form of compression. gzip is really cool, but use whatever you like, but do use compression. It can be orders of magnitude faster. Okay, JSON in favor of XML is a personal taste, but it's generally appreciated. And okay, HTTP caching is probably the most overlooked part of APIs. So who's familiar with HTTP caching? Okay, that's pretty cool. Okay, so a very recurring question when you design a mobile API is, I want to save bandwidth. So I want to make sure that once I've sent or retrieved something, I'm not going to have to do it again for a while. And that's actually a good idea, and it's already in HTTP, so don't reinvent the wheel. There is provision for caching in HTTP. It's handled by proxies. It's handled by all mobile devices, so really rely on it. Don't try to reinvent some form of custom-made caching, and just use the cache control headers, and you'll be good to go. Okay, the last one is probably only relevant for mobile, but it's really, really useful. Let's say, I'm going to give you guys an example here. Let's say you want to build an app for, well, I don't know, something that doesn't change that often, but that still does change. For example, okay, gas stations. Once in a while, a new one will pop in town, and you'll want to update your customers. Still, they don't change that often, so you don't want to send the whole list over and over again. So it's a good strategy to have a diff-enabled API. So the first time your customer connects, you'll send him the whole list, and let's say he comes back a month afterwards, you'll only send the difference, which is going to be so much shorter. Okay, so last but not least, that is definitely extremely important. Be careful with security, because basically there is no security, there is nothing you can do, so just know it. Here's an example. You're shipping a mobile app, for example, about movies, like we said before. And so you have this huge database of movies and actors and posters, everything. And you only want people to be able to use that API through your mobile app. Well, you can't enforce it. It's mathematically not possible. You can make it really hard, but you can't prevent it. So there are some things you can do, like using two-legged OAuth or HTTPS and checking for certificates. But once you've shipped some code to the public that's tapping into your API, anyone with anyone willing to invest enough time will be able to use your API. So just know it and be ready for the case where a third party will end up using your API. Okay, that's it, guys. So it's time for questions, I guess.
I'll ask you a question. On this topic of security, so you touched on the fact that nothing is secure, right? Anything you put on the phone, you have to assume can be retrieved. In practice, how are you dealing with that? You said you have to assume that third parties will have access.
Okay, so the topic about security is probably the most important one. You have to be careful when you talk about security, because there are so many different kinds of security. Here, the thing you can't prevent is someone using your API from somewhere else. That's pretty much it. So you have two solutions. Either use user accounts. For example, users have to log in, create an account, and sure, they'll be able to use your API from somewhere you didn't plan, but as long as they have to log in, you can turn off that bad user. So that's the first solution. The second solution is to, well, just don't care.
Tell about Siri as an example.
Okay, sure. So who has heard about Siri here? You know, the Apple thing? Okay. So Apple made this, well, pretty useless stuff. You're pretty much talking to your iPhone, and supposedly it understands what you say. And here's how it works. It's basically just a microphone that records what you say, sends it to a server where it's crunched, and sent back to your iPhone. And that's pretty interesting. And of course, the guys at Apple only wanted it to work with an iPhone, because since it's API-based, pretty much anyone could tap into the Siri system and use it from anywhere else. And okay, so when I saw Siri, I said, okay, there is no actual way they can prevent it from being used somewhere else. So I plugged in a sniffer, looked at what was going on the wire, and of course, after a while, I figured out how it was going on. And long story short, now anyone can use Siri from anywhere.
Did you do it?
He's the guy that hacked Siri, yes.
Yeah, okay.
He doesn't want to be killed by that.
Oh, sure. Oh, sure, it's completely illegal, of course.
But don't they have a security measure to prevent that?
So they do have a serial number into your iPhone. So each iPhone has a serial number, but as long as you're sniffing the traffic, you can extract the serial number and reuse it. Yeah, it's actually extremely simple. So, so they're just checking that the SSL certificate is valid. Okay, fair enough. Just resign your own certificate, and that's pretty much it. And behind the scene, it's a weird hack around HTTP. So it looks like HTTP traffic, but it's not actual HTTP. So the verb is ACE. So it's not a GET or a HEAD request. It's an ACE request. But that's pretty much it. It's just a web service.
So you managed to create an Android app that taps into Siri?
Yeah, I actually didn't do that, but yeah, anyone can.
Okay.
Once you have the spec of the actual web service. So it's when you speak, it speaks encoded. You know, the codec speaks, and then it's gzipped and sends. Okay. Yeah, it's really simple.
You have all the information on the blog.
Yeah, not anymore.
No. Archive.org.
Yeah.
Go to archive.org and look at the blog.
Okay, go ahead.
What's your opinion about providing the version of the API you want to use with HTTP headers instead of the routine? So the routine could be the same
Yeah.
different version. Is it a valid option?
Yeah, it is. I mean, whatever works for you is good, as long as you think about it before. You know, the real deal here is not to have clients somewhere that you can't update and that are a pain in the ass. So you have to plan the thing beforehand, and afterwards, everything's okay.
So what's your opinion about protocol buffers compared to JSON?
Okay, so you're talking about the Google thing, right?
Yeah, or the Facebook script, whatever.
Okay, so to be honest, I've never really looked into protocol buffers because it seems something like very proprietary, but I might be wrong though. I think the good thing about using regular normalized HTTP APIs is that you can develop them for mobile, but reuse them somewhere else. I don't know if I answered your question right. Okay.